Siemens Presence Detector White, CO2 Concentration and Control. As is becoming increasingly known today, the right CO2 concentration is, in addition to the temperature, an essential factor for feeling good in rooms. In workrooms and schools, it is even decisive for the achievable work and learning results. Since the 19th century, experts have been demanding that the CO2 concentration in such rooms should not exceed 1000 ppm in the long term. Unfortunately, in contrast to the still valid limit values for the so-called MAK values. MAK stands for Maximum Workplace Concentration. This discrepancy results from the fact that MAK values represent the absolute highest limit values for the health protection of people. That means they are regulated by law, whereas a specification CO2 concentration below 1000 ppm is a desired value for maximizing work and learning efficiency, for which there is no legal requirement. Whatever the user wants to do, the optimum can be achieved by exact measurement using Siemens KNX sensors and a suitable control function. Using the example of the Siemens Presence Detector White UP25851, this is explained here. Defining and setting up the measuring function. In ETS, we start again on the device settings page and activate the CO2 measurement. On the now available parameterization page, some essential factors for the measurement can be defined. With the help of offset and correction factor, the CO2 sensor can be calibrated in comparison with a reference sensor. The measured value can be released for sending to the bus, which is, for example, useful for visualizations. In this application, it is also possible to display the value as an integer according to DPT 7001 instead of the somewhat unhandy data point 9008 floating point ppm. By the way, the maximum possible measured value is 10,000 ppm. Finally, you can also configure again if the value should be sent when changes occur. Enable sending on value change and in which intervals. Configuration of the control function. The air quality controller must be enabled in the device settings. This results in a 3-stage controller which can be used to control a fan. This fan can have up to 5 speed steps. They are controlled either via 1-bit relay circuit, in this case a maximum of 3 steps, or via up to 5 corresponding 8-bit analog values. Make sure that you know the type of the fan and the type of actuator that controls it. As input, the internal measurement value can be used, which we have set and calibrated for this purpose in advance, or one or more external measurement values, which are then prepared via the calculation block of the sensor. If the fan is controlled by a relay, it must be clear how the relay evaluates the contacts sequentially. That means only the relay of the respective stage may be closed, or additively. That means all previous relays must also remain closed for stages 2 and 3. Finally, it should be noted that a sufficient hysteresis is required for switching back the steps, as here 200 ppm, to avoid frequent switching back and forth in the range of the switching limits. Here you can see the objects created after this parameterization for the case of 3-step control via switching objects. Objects have also been created for switching the control on and off and for overriding. You are now able to parameterize and commission the air quality controller, including the CO2 measurement correctly. Stay tuned!